So remember what we've just said is that if y is equal to um, log to base a of x, then dy over dx will be equal to 1 over x ln a. And I want to apply this in solving these two questions. So for the first one, a is 2, so dy over dx will be equal to 1 over x ln 2 because a is just 2. In the second case, this will be our x, and by the way, here we have a function inside another function. So we have to apply chain rule here. So dy over dx will be equal to the derivative of the inside part, which is 2, multiplied by the derivative of the outside. Now, the derivative of the outside will be equal to 1, because now the outside is the logarithmic function, 1 over our x is 2x minus 1. This is our x, so 2x minus 1 multiplied by ln of the base, and the base is 10, so ln 10. So our solution can be written as 2 over 2x minus 1 ln 10. Okay. Now, when we looked at derivatives of natural logarithms, we say that if y is equals to ln of x, then dy over dx will be 1 over x. So basically, number 2, notice that here you have that. So let me just write a statement here. So we said that not if y is equals to ln of x, then dy over dx is equals to 1 over x. So this is what we plan to use here. Okay. So in the first case, so for part A, we have to apply chain rule for part A by starting to you differentiate the inside followed by the outside. So dy over dx will be equal to the derivative of the inside, which is the derivative of 5x, just 5, multiplied by the derivative of outside will be 1 over our x, and our x is 5x, so that will be 1 over 5x. And that simplifies to 5 over 5x, which will just be 1 over x. That will be the required solution. And you can apply the same thing in the second problem. So this is what is inside. So apply chain rule. Dy over dx will be equal to the derivative of inside is negative 3. And then the derivative of the outside is just 1 over x, and our x is 1 minus 3x. So 1 minus 3x. So the resulting solution will be negative 3 over 1 minus 3x. Okay. Number 3. So we have this function, which is a product of two functions, and we want to find the gradient function. So we apply product rule because it's a product of two functions. So dy over dx will be equal to x cubed multiplied by the derivative of ln of x plus ln of x multiplied by the derivative of x cubed. And that will be equal to x cubed multiplied by 1 over x plus ln of x multiplied by 3x squared. And we can simplify this to x squared plus 3x squared multiplied by ln of x. That will be the required solution. For part um, 4, um, you can work out this question in two different ways. Probably the easiest way will be if you apply laws of logarithms. You know that uh, when you have a product, you can rewrite this as y is equals to ln of x plus ln of e to power negative x. Um, so basically, dy over dx will be equal to 1 over x plus, here you can find the derivative of, well, actually here, let's rewrite this. You This can be written as ln x plus negative x. If you bring this in front by applying laws of logarithms, this will be equal to negative x ln e, which will be equal to ln x, and ln e is just 1, so minus x. So if you find the derivative of that, so the derivative of ln x is just 1 over x, and the derivative of negative x will just be negative 1. And therefore, you can rewrite this as, you can leave it like that, or you can write it as 1 minus x over x. Okay, so that's probably the shortest way to work this out. The other approach is you can find the derivative of the inside and outside, but now you'll be forced to use product rule, which could be time consuming.